Now, here for this part here, we will be looking at air conditioning processes. Now, air conditioning processes involve heating, a simple heating process, a simple cooling process, a cooling and dehumidification process, plus heating and cooling with dehumidification and heating with humidification. So these are the 4 processes involved in the air conditioning processes for your diploma level. Now, maintaining a living space or an industrial facility at a desired temperature and humidity requires some processes called the air conditioning processes. Now, these processes include heating, okay, that is to rise up the temperature, cooling, that is lowering the temperature, humidifying, that is adding moisture or water vapor to the air, and dehumidifying means removal of moisture or water vapor from the air. Now, sometimes 2 or more of these processes are needed to bring the air to a desired temperature and humidity level. Air is commonly heated and humidified in winter and cooled and dehumidified during the summer. So these are all mostly the air conditioning processes. We are not looking at theater, we are not looking at halls and all those things, okay? So these are the simple processes involved only in thermodynamics, okay, for diploma level. So I have shown you your psychrometric chart. So basically, I'll repeat once more. So here is where your DBT, that means the dry bulb temperature is. And here where is your specific humidity is. Okay. Then you have your wet bulb temperatures along this line here. Okay, and these are the processes that we have. Okay. Now, first thing is humidifying. Humidifying, that means adding moisture to the air. So when you add moisture to the air, what happens is the specific humidity will increase. Because specific humidity is defined as the mass of water vapor divided by the mass of dry air. So that is where you have mV over ma. So the mass of water vapor that appears in the 1 kg of dry air. So humidifying means adding moisture. So when you add moisture, definitely the specific humidity will increase. Then you have heating and humidifying. So when you combine the heating and the humidifying process both together, you have what we call heating and humidifying. Okay, heating is on this line here. As you can see, heating, this is a horizontal line. That means it involves in no change in specific humidity. It involves no changes in the specific humidity. So during the heating process, usually the specific humidity remains constant. Okay? So because during heating process, this is only to heat, to bring up or to raise up the temperature, not involving in vaporizing, or because the water vapor in the air is already in the superheated stage. There is no way of further vaporizing it because it's already a vapor. So that is why the content will remain constant. Okay, the content will remain constant. So when the content remains constant, when the capacity is increased and the content is reduced, okay, no, the content remains constant because there is no removal of moisture or no adding up of moisture during the heating process. So that is why the specific humidity is constant, but the relative humidity actually drops. Okay, so if let's say for example you refer this point here as 0.1 and this point here as 0.2, you can see when it moves from 0.1 to 0.2, that means towards the right hand side, right hand direction, you can see that will show you the decrease in the relative humidity. Now humidity is defined as relative humidity is defined as moisture content over moisture capacity. So when the moisture content remains constant, whereas the capacity increase because you are heating it, so the capacity will definitely increase. It's just like the space in between air particles. The air particles will tend to move further away from each other, but then the content remains constant, so the relative humidity will drop. The relative humidity will drop during the heating process. Then heating and humidification. So if you plus heating with dehumidification, you have this process. But then usually we don't have heating and dehumidification for now. Okay, then you have the cooling plus dehumidifying. Now cooling plus dehumidifying here involve a cooling of the air until it becomes saturated. It involves cooling of air until it saturates. So when we say air is saturated, that means it no longer can take in any more moisture or water vapor moisture content. So what happens if it's subjected to further cooling? That is when, okay, the H2O or the moisture will drop out from the air as condensate or dew. Okay, so that is a way which dehumidification will take place. Then you have cooling process. The cooling process also involves in constant omega. So as you see this horizontal line here, this direction refers to heating, the other directions refers to cooling. So heating involves in increase in dBT, but cooling involved in the decreasing in temperature, the dBT temperature. But the omega will remain constant because there is no changes in the content, the moisture content still remains the same unless if you cool it until it reaches its relative humidity of 100%, this purple line here, 100%. Then further cooling will cause dehumidification and will cause a drop in moisture, this moisture content as well as this specific humidity. Okay, that is the cooling process, and we don't see any cooling plus humidification process yet. Okay, so these are the various processes that we have in air conditioning systems. But then you need to mix and match. It depends on the desirable, desirably, how much of what are the conditions that the manufacturer or the company wants to how to say do the aircon system. Okay, so you have to mix and match. Maybe you have to have heating, and then you must have cooling, then you must have humidification and dehumidification. It depends, it really depends on the applications, that means the environment. So this is a simple heating and cooling process. So I have here the heating process. So the heating process, so as the air enters the duct, okay, as the air enters the duct going through the heating coils or the heating elements, the dBT1 here will change to dBT2. Omega 1 and omega 2 should be the same. Omega 1 should be equals to omega 2 during heating and cooling process. The omega must be constant, whereas the relative humidity here, okay, Now it drops as it goes through the coil. As it goes through the heating coil, okay, the relative humidity will drop. Why it drops? When the content remains constant, because the capacity increase. So when the capacity increase and the content is constant, the relative humidity will drop, because relative humidity is defined as moisture content over the moisture capacity. So that is what you have. And usually we take the mass flow of A entering and leaving the duct DUCT to be the same. Okay, the mass flow of A is the same unless you have a mixing process which involves in mixing A of different qualities. That means a mixing chamber. So otherwise, the mass of flow of air through a single pipe like this usually is taken as to be constant. And the omega as well is constant, okay, because there is no increase or decrease in the moisture content. So the heat supply to the air is equals to the change of enthalpy multiplied by the mass flow of air here. Okay, so that is a heating process. That is this. So see, look at the arrow. So it's pointing towards that direction. That is for heating process. So you see, I have put a marker here. That is heating process. Okay, so as the air particles flow through the heating coil, what happens is the dBT, the dry bulb temperature, will increase, the specific humidity remains constant, the relative humidity drop. Okay, the omega remain constant. So the next one is the cooling process. It's the cooling process. So it goes through a cooling coil, and I've said, okay, omega is constant during only cooling process. Only cooling process. We are not talking about cooling plus dehumidification. We are talking about cooling process only. So omega 1 should be equal to omega 2 as well. But then the relative humidity you can see as it is shifting towards, the left, that means to the left. That means the relative humidity increase. If it is shifting towards the right, the relative humidity will drop. Okay, so omega is constant, and then you can find the heat rejected. Okay, the heat load, the cooling load. Okay, the cooling load. Okay, is equals to the product of mass flow rate of air with the changes in enthalpy. So that is your relative humidity. Your dBT will drop, omega constant, relative humidity increase during a cooling process. Okay? So cooling process is here. Okay, so it's again a constant omega. So now the next process here is the heating with humidification. By injecting, now this humidification and heating process here can take place, especially when you are injecting superheated steam, okay, superheated steam, or dry saturated steam, superheated steam. So what happens is it will actually heat up the entire mixture of the air and water vapor. That means in the air. So first it goes through a heating coil where it undergoes heating process. Then it goes into the section which is called the humidifying section. Humidifying section is where the section where you add in moisture content. You add in moisture to the air. Okay, so you have the mass flow of air constant throughout because single line again. And then, okay, you can relate that to a water because omega is equals to what? Mass of air over, mass of water vapor over the mass of dry air. Mass of water vapor over mass of dry air. So if we want to find the mass of water vapor or how much of water extracted or removed, then you have to change the mass flow of A in terms into mass flow of A times omega, which give you the mass flow of water vapor. So you can do that as the when you are looking at the continuity equations, okay, or the balance, mass balance. So when you look into energy balance part, then you have this equation here. Again, your Q in is equals to this. Okay. So now for the heating and humidification process, as you can see, 1 to 2 here is a heating process, and from 2 to 3, or maybe it goes further up, because if let's say you are having a superheated steam here, point 2 here might shift to another point 3 maybe slightly, and then it will have an increase in specific humidity because you are adding in moisture here. You are adding in moisture, you are adding in superheated steam to the air. So maybe you have 0.2 to 3 because here it involves heat transfer from the superheated steam to the air. So your 0.2 might move to another point that is along this horizontal line here towards 0.3 and then vertically up. So because that is the humidification part. Okay, so then you can draw the last point, sorry, the initial point to the last point in order to get the heating and humidification. Okay, so this is a heating plus humidification process. So that means that involve 1, 2, and you get 3. So this is your heating and humidification process. So here you have heat wave, okay, heat wave, okay. So you are heating the air particles actually when it goes from point 1 to 2, state point 1 to point 2, and then it's moved from state point 2 to 3. It undergoes maybe a slight heat addition and then plus moisture. Okay. Then you have cooling and dehumidification. Now, so you can see this part here, okay, 1 to 2 is a cooling process. So 1 to 2 is constant omega, so it's a horizontal line until it touches this purple line here, or this curve here, which is having a relative humidity of 100%. So as it reaches 100%, any further cooling will cause the drop in specific humidity. That means will cause the removal of moisture from the air. So you follow this path downwards until you reach a new omega 3. Okay? So that means in this process is actually extracting water particles from the air. Okay, it is actually extracting water particles, moisture from the air. Okay, so when the air is cooled, that means this cooling coil actually must be long enough for the air particles to be cooled down until it reaches its saturated condition, saturated air. It must reach 100% before you can remove any moisture from the air. Okay, so this is dehumidification plus cooling process. Okay, so that is here, the 3. So you have cooling plus humidifying, you have cooling and the humidifying process. Okay, so the same mass flow of air throughout is constant. Okay, so if you want to find the water mass balance, you can use this equation here. And then if you want to find heat in or heat out, okay, you need to use your energy balance again. Okay, that's all for the air conditioning processes. And there will be tutorials for this chapter here or this section here. So that will be given in a later date, unannounced, cannot announce yet. Okay, so here is your podcast. Thank you very much.